Hello and welcome back. Probably preparing for mocks and revision for AS, further maths and matrices. Show that the matrix M is non-singular. Well, these questions are good for regular A level as well as AS level. But when we're trying to show that the matrix is non-singular, we have to determine M is not equal to, the determinant M is not equal to 0. So we'll write that. We'll make sure that we can arrange that. So let's do the math. So let's make sure that our is okay. And 1 second here. Yeah. Okay, let's start. Alright, so we're going to show that the determinant M is not equal to 0. So we've got our matrix which is 4 times minus 7. So we've got 4 times minus 7. Here we go, 4 times minus 7, and it's minus 5 times 2. So minus 5 times 2, and that is equal to that's minus 28 plus 10, so that's equal to minus 28 plus 10, and that gives you minus 18. So minus 18 means that the determinant M is not equal to 0, and therefore we can say not equal to 0. So that means that it's non-singular. So when you use matrices like this, it's sensible to always tell the examiner that, well, it's either equal to or not equal to 0. And part B, the transformation T of the plane is represented by the matrix M. The triangle R is transformed to the triangle S by the transformation T. Given that the area of S is 63 square units, B, find the area of R. Well, in order to do that, we need to use matrices, or let's write it out. When you use matrices to transform shapes, any shapes, in this particular case it's a triangle, the modulus of the determinant, the modulus of the determinant is the scale factor. So this is what we need to know in order to progress. So let's extend the page, and so for part B we have, well, it says the area is 63 square units. So if we do 63 divided by the modulus of minus 18, which is what we found, that doesn't look like an 8, yeah, minus 18, we should end up with 3.5. We end up with 3.5 because we take the positive value, of course, and that's it. Nothing further to do. So in other words, 3.5 times 18 gives you the area of 63. You can say 3.5 times 18 is equal to 63, which is the area. Part C, that's another 2 marks secured there. Part C, show that the line y is equal to 2x is invariant under the transformation of t. Well, we need to go to our vectors. Now, if the line y is equal to 2x is invariant, then we got 4 and minus 5. 4 and minus 5. Alright, let's just erase this bit here. 4 and minus 5. And we got 2 and minus 7. 2 and minus 7. And we're going to multiply that by x and 2x. because that's going to lie on the line x and 2x, because we're looking at x and y coordinates, and this will give us, of course, 4x minus 10x. So that will give us 4x minus 4 times x and minus 5 times 2x. So that gives us 4x minus 10x. And on y we'll have 2x minus 14x and 2x minus 14x. And there you have it, because we have 4 times x, 4x, minus 5 times 2x, that gives us minus 10x, 2 times x, and minus 7 times 2x gives us minus 14x. So that will give us, let's just extend the page again, that will give us minus 6x and minus 12x. Minus 12x. Now, that's nice because I can take 6 out as a factor. If I take 6 out, or minus 6 as a factor, I'm going to end up with x and 2x. X and 2x. And that means that the points on y is equal to 2x, this means that points y equals 2x maps onto the line y is equal to 2x. Maps onto the line y equals 2x. And I believe that's your 6 marks. 2, 2 and 2.